Hi, welcome to Zona Mechanica. There is an MCQ on bolted joint. Figure at the margin indicates the weightage of the question, that is 2 marks. A bolted joint is shown below. The maximum shear stress in MPa in the bolts at A and B respectively are. There are 4 options given. There is a bracket with 3 designated holes for 3 bolts to fix it, and the plate thickness is 6 mm, and the force of 10 kilonewton is acting over here. The question is, due to this load, how much shear stresses are acting at the bolt A and B? Well, the solution of this question will be a bit lengthy, but it's an important one. So first of all, the bolt sizes are given as M10 by 1.75. That is, the shank dia of the bolt is 10 mm. Okay, suppose this is the threaded portion. Okay, so this dia, shank dia, is 10 mm. Okay, so this is the bolt inserted over here to fix the bracket. Okay, so as you know that these 3 bolts will share this load. There will be working 2 types of loads in the bolts. One is primary load and another one is secondary shear load. Okay, see, the fraction of the direct load carried by each bolt is known as the primary load. So if PP be the primary load shared by each bolt, then it will be F by N. N is the number of bolts. Okay, so it will be 10 kilonewton, that is 10 into 10 to the 3 newton by 3. So it will come around 3333.33 newton. Okay, so this is the load shared by each of the bolts, which is known as primary load. Okay, now the secondary load. See, the load is acting away from the bolt axis, right? That is the CG of the bolt system. See, clearly all the 3 bolts are aligned, so the center of the position B is the CG of this bolt system, right? So the load is not acting at the CG, it is away from the CG of the bolt system, so it is called eccentric load. So due to this eccentric load, there will generate a moment which is equal to this force into this distance, that is this F into this eccentricity. See, clearly this will be a clockwise moment, right? F into E. A clockwise moment will be generated, right? See, due to this moment, an additional load will be generated in these bolts. This moment in turn will try to pull this bolt towards the front side and this bolt towards the back side, right? So the force acting in this bolt is known as secondary force. Okay, PS, secondary force. And the primary forces shared by each bolt will be downward. So these are the primary loads, PP, PP, right? This is the primary load, and these two are the secondary loads. See, in bolt B there will be no secondary force because the bolt B is at the CG. Now the secondary shearing load PS will be given by F into E into RA by RA square plus RB square plus RC square. What are the RA, RB and RC? See, RA, RB, RC are the distances of bolts A, B, C from the CG of the bolt system. Okay, see, CG of the bolt system is nothing but the center of the bolt B. So the distance from the center of B of A is RA, which is nothing but 40 mm, and that of bolt C is RC, which is also 40 mm, and bolt B is 0, right? This is 0, so it will be F is 10 into 10 to the power 3 into eccentricity is 150 and RA is 40. See, this is in Newton and this is in mm, this is in mm, so Newton mm square, and this RA is 40 square plus this is 0, this is 40 square. See, clearly this is also mm square, so it will be in Newton only, right? So this will come around 11.72 Newton. Okay, so this is the secondary shearing load which will act at A and C. Okay, not in B, since the distance of B from the CG is 0, so this will be 0, RB will be 0, so PS for B is 0. Okay, so now P net will be root over of PP square plus PSA square plus 2 into PP into PSA into cos of theta, right? Where theta is the angle between PP and PS. Clearly this angle is 90 degree, cos 90 is 0, so this will be PP is 3333.33 square plus PS is 11.72 square, right? Plus this is 0. Okay, so this will give some 3333.32 Newton. Okay, so this is the net force acting at bolt A. Okay, now the shear stress acting in A will be P net by the area, right? Cross sectional area of the bolt. See, this cross sectional area of the bolt will be 3333.32 by pi by 4 into d square, right? See, d is 10, right? The shank dia of the bolt is 10 mm, so this is Newton per square mm, that is in ampere, right? So this will come around 42.44 ampere. So this is the maximum shear stress which is developed at bolt A. Now the shear stress at bolt B, that is the load acting in bolt B by the area, right? Cross sectional area of the bolt. See, in B only the primary force is acting, right? That is PP by area of the bolt, right? Cross sectional area of the bolt, that is 3333.33 by pi by 4 into d square, that is 10 square, right? So this will also be in MPa. So this will come 42.44 MPa. Okay, both are coming 42.44. Clearly it's matching with option C. So option C is the correct answer. Hope you have understood. If you are enjoying, please do share with your friends. If you are new to our channel, please do subscribe it.